Okay, hey guys, I'm sorry this set of videos is very late. I was traveling last week and that threw my entire schedule off. So I've been trying to play catch up ever since. But, okay, so this first video, these are the videos for tutorial 3. And this first video doesn't really belong to any of the problems, but I just wanted to emphasize a point that the professor has been making in class about sign conventions and graphs. So you should have seen the professor for the last few classes. He's been drawing his moment diagrams in a funny way. They're not funny. They're just funny to you guys. This is his moment diagram. He draws it with the axis downwards, and sometimes he'll draw his graphs like this, where this in case he's starting from the left and going to the right. In this case, he's starting from the right and going to the left. And I just want to show you that these two graphs are equal. All that you have to keep track of is how you draw your equations. So let's try. Normally, when we work with graphs, we assume that we have a positive axis, something like this, where this is positive for the y and this is positive for the x. We normally work with something like this. And the equation for y equals x can be drawn with a straight line that's going from the origin in the positive x and y directions. And it's just a straight line, right? But do you agree that I could just rotate? I could just flip this axis. I could flip this graph about any of its axes and it would still be true. For example, what if I look at a graph? What if I drew my x-axis going the opposite way? I drew my x-axis going like this. And this is positive, and this is my positive y. Now my x equals what? My y equals x graph would again be a straight line, but be starting from the origin and going in the positive x and y directions. So this would be my positive graph. Nothing's changed. These two graphs are equal. All I did was I flipped the axes around. When I flip it about the y-axis, the graph has to change in order for this equation to still be the equation of that line. Let's try another case. In this case, we have, this is my positive y, and this is my, this is my positive x. Again, in this case, my y equals x line is just like this. Right, I have this graph. I flipped it about the y-axis. I made my positive going downwards instead of upwards. And if I do that, then this is my y equals x graph. Nothing changed with the values. This graph, this line, is represented by this equation on this coordinate system. This is why you always have to specify your coordinate systems. If you can specify them, it allows you to be flexible with them. If you're flexible with them, you can save you a lot of trouble with having to mess around with funny angles. Or not just funny angles, but funny values. Finally, let's look at one last graph. In this case, we're going to start from, I think this is the last possible permutation, but we have a line like this. And this is my y equals x graph again. Again, these graphs are all equivalent. So you do not have to, do not freak out when the professor starts drawing these graphs in funny directions. They're all equivalent. If you draw your graphs like this and you get your equations for this line, remember that you have to flip the way you draw your diagrams. If you treat this as your positive coordinate, let's see when this would come into play. For example, let's say you have a simply supported beam. If you make a cut here, I could look at it from the left or from the right. let's pretend that I look at it from the left, and what do I get? I'm gonna have to, if I do my x, it'll be like that, and my y, I'll call this x prime, will be like this. When I'm looking at my graphs, this could be my shear, for example, and this could be my moment. Let's pretend that I have a distributed load on here also. I should have drawn that earlier, but let's pretend that I have a distributed load. My shear is going to be something like this. My moment is going to be something like this. And this is if my positive shear is going upwards and my negative moment is going downwards. Over here, I get something that looks like this. Sorry. And on the right side, again, I would get something. I'm mixing up my colors. Like this. I would get something that looks like this. And when I put these graphs together, I get the normal shear moment diagram that I would expect. This is my moment. Notice that here my arc switched. It's because here my moment was going downwards and here my moment was going upwards. So you can draw your diagrams any way you like. And I just wanted to emphasize that point for you here. This first, okay, so that is that. The next video problem is going to be on problem 1. I'm going to find the reactions and I'm going to show you how to draw the graphs from CD to DE. And I'm not sure yet how much of the next, I'm definitely going to cover something on problem 3. I'm not sure how much I'm going to cover on problem 2. And problem 4, I'll give you guys a couple hints, but I'll let you guys work through problem 4 for the most part by yourselves. So yeah, you can just jump to the video that you need now.